Hi everyone, this is Gisneria Dominic. Welcome to my presentation, and my presentation is about applications of logic gates. So before we discussing about the application, we must have a basic knowledge about what is logic gates. So basically, logic gates is a device that acts as a building block for digital circuits. So it is the building block for the digital circuit. That means a digital circuit is building or built up by logic gates. Without logic gates, we can create a digital circuit. So they perform basic logical circuits, logical functions that are fundamental to digital circuit. So AND, OR, XOR, NAND, NOR, XNOR are the basic logic gates. The first one is application of OR gate. Whenever the occurrence of any one or more than one event is needed to be detected or some actions are to be taken after their occurrence, in all those cases, OR gates can be used. For example, suppose in an industrial plant, if one or more than one parameter exceeds the safe value, some protective measures is needed to be done. In that case, OR gate is used. So I'm going to show this with the help of the diagram. So here we're using an OR gate, and using this OR gate, we can dictate the exceed. We can dictate whether the temperature is exceeded or the pressure is exceeded, and so that we can produce a command signal for the system to take required action. So this is the OR gate that we used in this system. The next one is application of AND gate. There are mainly two applications of AND gate. First one is enable gate and the second one is inhibit gate. Enable gate means allowance of data through the channel, and inhibit gate is the opposite of that. We just reverse the process, that is disallowance of data through the channel. So I'm going to show an enable operation to understand it an easier way. Suppose in a measurement of frequency of a pulse waveform, for measurement of frequency, a gating pulse of non-frequency is sent to the enable the passage of the waveform whose frequency is to be measured. The diagram below shows us the arrangement. Now we can see that in this diagram we have used an AND gate to enable the circuit, right? And the clock pulse is given. So this AND gate is act as an enable gate. The next one is application of XOR gate or XNOR gate. So in this figure we can see this is the XOR gate, and these type of logic gates are used in generation of parity generation and checking unit. So these two diagrams above shows us the even and odd parity generator circuit respectively for data. So this figure shows us the even parity generation, and this figure shows us the odd parity generation. So in this figure we can see the output. With the help of these gates, parity check operation can also be performed. The diagram above shows an even and odd parity check. As we said before, as we discussed in the previous slide, we have shown the even and odd parity check. So figure A shows us a parity check using XOR gate. So first one is the parity check using the XOR gate, which is even parity check. And the figure 2 shows us the parity check using the XNOR gate, which is odd parity check. The next one is application of NOT gate or inverters. We know that NOT gate is basically complement the input that we have given. So, for example, if we give input as 1, the output will be 0. So the NOT gates are also known as inverter. This is because they invert the output given to them and shows the reverse result. Now the CMOS inverters are commonly used to build square wave oscillators which are used for generating clock signals. The advantages of using these is they consume low power and their interfacing is very easy compared to other logic gates. So in this figure, we have used three NOT gates, 1, 2 and 3, and we got an output. So the above figure shows us the most fundamental circuit made of ring configuration to generate a square wave oscillator. So as we already said, NOT gates are basically used to create the oscillator, square wave oscillator. So this is the fundamental circuit that needed for the square wave oscillator. So so far we have discussed the applications of OR gates and gates XOR and XNOR gates and NOT gate. This is all about my presentation and thank you for watching.